Hey there guys. So today what I want to do is just look at a model that I've built. I actually built this a little while back. I've done a few updates now, but what I wanted to do is just very quickly go through this model. For one reason is actually because I think it's a pretty cool model, so maybe you guys will enjoy using it. It's very high level, which is effectively what a model always is. It's just a high level representation of a real underlying process, but it's a high level approach to kind of figuring out your kind of lifetime budget is what I've called it, right? Lifetime budget. Um, Basically what it is just a series of pretty simple inputs. It does a bunch of calculations off of those inputs using possibly some assumptions, and I'll go through those in a bit. And then ultimately you get a couple of outputs which you may find interesting. Hopefully find interesting, because that is the point of the model. Now you can have models for a whole host of things. This one in particular is just trying to model out effectively your financial life going forward. That being said, this has had no kind of testing in the real world, so it's simply a something that I've put together for fun. But hopefully it's something that can facilitate kind of understanding about how models at least are well, the design process for creating a model. So the first thing I'm going to talk about here is format, and I know I harp on a lot about this, but it's something that I see oftentimes not being thought of when building Excel spreadsheets. You'll notice once again I've got that kind of column over here. Now, like I said, I created this model a while back, at least the first version of it, and yeah, so clearly I do that all the time. So maybe I should have made that macro, that add in years ago, would have saved me some time. But anyway, um, the what you'll notice, there's two sections to this spreadsheet. There's a kind of a section at the top area and then a section below. What I've done here is I've put the assumptions and the inputs into the model all at the top, mostly all at the top. There is actually this column here, which is in the bottom area where you can make changes. But all the areas where there is kind of like a blue or purple cell coloring are areas which you can change. And so you have your inputs being the blue areas, and your assumptions, which are also inputs, just a particular type of input. And at least these assumptions are particular assumptions, like quote unquote financial based assumptions, right? And we'll come on to those numbers in a moment. But you have those, you have those for various categories. So personal details, indices, your housing costs and assumptions around that and inputs around that. Children that you may want going forward, and the potential cost of those kids each year. And then some outputs, and I've only got one output here, but you could have multiple outputs. In the original version of this model, I actually had another output called early retirement, which is quite an interesting thing, and I'll actually show you a website where I kind of got this idea for building this model in the first place, which is pretty cool, a website, just if nothing else, just for some fun reading. And also some idea generation, I think. So as you can see, everything there is listed at the top. And what's intriguing about that is there's very few, if any, calculations in this area. I mean, there's a calculation here just to turn like annual costs into monthly costs. And there is, I think this calculation turns an annual rate into a monthly rate. So that's just like a pretty simple calculation there. It's, instead of it being 5% every year, it's 0.4% every month. Now what we have below here is where the kind of the model engine, I guess you could call it, or just the kind of series of calculations occur. And going into that, you have a series of kind of initial calculations on this side. You have calculations related to housing over here. You've got calculations relating to children over here, and kind of calculations relating to outputs over here. And what's nice about that is, again, everything is kind of split out in comparable regions, I guess, or consistent regions, for want of a better word. So that means this model, in my opinion, very easy to understand off the bat. You open it up, it's quite self-explanatory. Now, I could have been a lot better with headings. For instance, I mentioned this is annual and that's monthly. I don't have any labels there. Probably want to put those in to make it a little bit more readable. But the person wouldn't have to spend much time at all to figure that out very quickly. So not a huge deal. When you look at it, I guess not mainly also because it's under heading indices, and indices you would expect things like annual and monthly percentages or rates. So therefore, you wouldn't, this isn't out the realms of possibility for numbers you'd expect under that kind of heading, so you'd work it out very quickly. What you might have in annoying situations is where there is no relation to the number to the heading, or there's no heading at all. And then that's when the model is very poorly documented, in my opinion. So anyway, looking at the spreadsheet, what does it do? Again, I think this is incredibly intuitive, given that these are the kinds of things most of us have probably thought of a number of times in our lifetime. And that is, what is our monthly expenses? What is our monthly incomes, and do I have enough income to offset my expenses month on month? And also, how will that look over time? So the current month is here, and each month is a separate row going into the future. And if we start on the first month, basically what it does is it takes those initial inputs and puts them in to a series of columns. As I mentioned, the columns kind of relates to the headings above, largely. Not exactly, but largely. And what you have is the ability to see, okay, for this year, you started with that amount, and you ended with that amount because of a series of impacts. So the obvious ones here, we've got salary, we've got like if you get a bonus, an annual bonus or some kind of bonus. You've got the kind of monthly expenses, which are called, it's like daily expenses in monthly form. What is your rent? Do you have any one-off expenses? So those are kind of the simple, large things that you think about every month. Then the things relating to housing. So I've got a few fields here, which are all based on what you input over here, which I'll come to in a sec. You then have the amount of cost for each individual child, and that will be dependent on when they're born and depending on this index of monthly cost. And then lastly, you have those final calculations, which also allow for interest on any kind of savings that you have. And all these calculations actually change over time. So as you can see, the salary increases over time. Your expenses increase month on month. And this makes sense, right? Usually you get a salary increase once a year. And usually your all monthly living expenses, whatever, increase all the time. It's, constant inflation. So that makes sense from that perspective. And those you can just see very simply, kind of starting salary, and then your raise should occur in month 3, which is March. And how much does it increase by? Well, your wage inflation, right? So that's this factor, 4%. And like I said, I've kind of just thrown in random numbers here. Not numbers that would be a million miles off what's possible out there in the real world, but those aren't accurate numbers by any stretch of the imagination. It's just a good example. But you have a look in your interest, assuming you're making a whopping 5% on your investments every month, which is phenomenal. Boom, you're getting that kind of return there. at least a monthly return of 0.4% on your savings. And if you have a mortgage, your mortgage rate is that percentage there. And those calculations just all feed through. So I've already shown you these ones. The bonus gets paid, which includes annual wage inflation. You've got your daily expenses, or monthly expenses, I guess you want to call it. You've got your rent. Your rent, however, ends when you buy a house. And your house calculations here, you've got two different strategies. Your first strategy is, well, you can buy a house sometime in the future with a certain value, but you need a deposit of, say, 20% in this case to be able to actually make that payment. So yeah, the 20% paid, and you've taken out that actual mortgage value for that house value. And then your repayments will be calculated. It's just standard mathematical, like financial based calculations. These look a little bit more complicated because they kind of allow for all these things and all possible strategies, which is one of the cool things about Excel. You can kind of throw in a bunch of possible options. As you can see, this is like, if it's one, then do something, but otherwise do something else. So you can get quite a lot of cool features into a model by kind of allowing for those if statements. And then you have kind of two different strategies how you actually pay that mortgage back. You can either pay fixed payments. What you can also do to a fixed payment regime is to kind of throw in your entire bonus if and when you do get one to kind of reduce that mortgage over time, but you don't have to. You can put that at 0%. That's strategy one. Strategy two is that you put every single last cent into that mortgage to pay it down as quick as possible, but you keep some kind of cushion. And then these calculations all just work, at least as far as I've tested it, which is not super comprehensive, to be fair. But at least as far as I've tested it, these calculations, changing those strategies will kind of change the type amounts that you pay back and how long you land up then paying back that mortgage. And ultimately, I'll quickly touch on the children. If you want to add in a child, just add in when they're going to be born going forward. Or you could add them in the past and you'll only see the amounts going forward for like their current age. Say they're 8 now, you'll just see 8, 9, 10, etc. with the corresponding costs, which is, by the way, a very nice use of Vlookup. If you're not used to Vlookup, there's a Vlookup in there, and because Vlookup basically says what is the age of the kid at the moment, and then it will pick up the correct cost of that age group for that month. So that's quite simple, actually, how that all works. And then ultimately, you add and subtract all of those numbers, and then it tells you ultimately, after you allow for investment income, what is your kind of end result. And interestingly there, if you have a starting amount and an ending amount, you can see how much of your salary over here, or your incomes, I guess another way to think about it, how much of those have you saved? And, well, over here, it's at 41.3%. Now, the reason why I built this model, like I said, there was this website. Here it is. So it's MMM. It's quite a fun website. And there's this great post from 2012, the shockingly simple math behind early retirement. Basically, whatever your savings rate is per month, will determine, like, if you get that consistently to a particular level, and then therefore it will improve over time because you're obviously making hopefully more money than you're paying off over time, so that will constantly increase because of investment income and stuff. You get the situation where you can actually work out roughly when you'll be able to retire, and it's based on some underlying assumptions which may or may not be totally accurate, so you need to look into the numbers a little bit more, but as a very high level perspective, this is very interesting. And basically it says if you've got a savings rate of 64%, you can retire in 11 years, right? So going back here, you could apply that same formula over here and say, well, what is my savings rate in, like, at that period? And then if that's the case, I should be able to retire in X number X number of years. The other way, using this model, is you could actually just scroll down to where you get to, say, 100% savings rate. So when your savings rate is 100%, it means you're bringing in a salary, right? But none of that money needs to be spent on anything because you're making all that money from, say, investments and whatever. So actually working at that point becomes completely pointless. I mean, you're just making money that you don't ever intend on spending. So I mean, you could have that if you really wanted to, but if you wanted to go ramp up your lifestyle. But in terms of just keeping your current lifestyle as is, you could retire at this point. So that was kind of the initial motivation for building this model, and that website's quite quirky and quite fun reading as well. So yeah, I think this is. So what I'm going to do, I'm going to release this in the next couple of days onto a place where I upload my models. It's called Github, and that's somewhere where people upload a whole bunch of stuff, usually like code-related things. So I'll upload my model there, and feel free to have a look at it. Have a look at like the formulas that are in each of these columns. I've got quite a lot of different formulas in there, and some of them are pretty complicated. Where I find the complications can arise in a model like this, but where you get a huge benefit from Excel is when you start referencing the values above the cell when like looking at your calculations in a kind of tabular format, right? So these guys kind of use all the information beforehand to work out what the value should be at that point. So an example of that will be with your mortgage repayments. You need to know going back in time kind of what your mortgage looked like. One of the things that you need to know at least is have you started your mortgage process? If you're over here, you shouldn't be paying any kind of mortgage, and you won't have a mortgage. You only kick it off after you've accrued enough of the deposits, but your calculations need to allow for that. So there's different ways to do it. You can make it you can add a lot of columns and then show your kind of steps. The process I've done here is very likely not the easiest, but it's one way of doing it, and I thought that would be interesting to show you guys. So some of the formulas are really easy, but some of them are pretty complicated, and but nothing too complicated. Once you start breaking them down, just look at that part of the formula. What does it do, right? And then when you look at this part of the formula, all that is just adding on interest to that amount, because that payment will be happening in the future rather than right now. So $2,000 or pounds or whatever today is not £2,000 in the future. It would be £2,200, £2,400. So using these interest rates, so or inflation rates, I should say. So this calculation allows for that, and allows for depending on what kind of expense it is, we'll use different indices. So all these calculations are actually, there's some relatively complex calculations, but nothing out the kind of realms. That's why I've kind of dubbed this one a bit more of a kind of basic model analysis, because ultimately we don't have things like offsets, indirects. Those things tend to be a little bit more complicated to understand. Another thing that's really complicated, I think, advanced, is array formulae. And those are things that I'm pretty excited to kind of explore, not only what they are and how they work, but also because that's a bit bland. Let's see how we can actually apply them into a real world scenario, just like we've applied a Vlookup here to a real world scenario, to get an interesting use case out of it, and then that hopefully will kind of cement the idea of how to use it, as well as the actual kind of wording of it and what it needs to look up. So I guess that's the end of this quick video. If you have any questions or any comments at all, please let me know in the comments below. Feel free to give me a shout on any ideas that you might, of things that you might want to see out of this series. I'm not really sure. I don't have like a set plan on exactly what things I'm going to look at. I have some ideas of stuff that I think might be quite interesting. I wouldn't be surprised if at the end of the process we are looking at making games, making kind of like, graphics engines and things like that. But let's see how we go. Although I'm sure there's a little bit of interest for that too. But yeah, until the next one, guys, take care and see you then.